Intermediate Algebra for Statistics, Section 2.1, Expressions. Lesson objectives: evaluate expressions, translate English phrases to and from mathematical expressions. Lesson objective number 1. An expression is a constant, a variable, or a combination of constant and variables, operation symbols, and grouping symbols, such as parentheses. Here are some examples of expressions. T plus 6, pi, L plus W minus 9, Y, 4, and 5 divided by the quantity X plus 2. So all these are expressions. They can be numbers, they can be variables, and they can be a combination of both involving operations. Which of the following is not an expression? Number 3, 3x minus 8 equals 9 is an equation because it has an equal sign. Example 1. Hot dog stand sells hot dogs for $2 a piece. Find the total cost of buying the given number of hot dogs. Number 1 is 3. Problem number 2 is 5. 3 is 8. And number 4, use the variable n, hot dogs. So for 3, we simply take 3 times 2, and that equals 6. Number 2 would be $10 because 5 times 2 is 10. Number 3 would be 16. Number 4, in problems 1 through 3, we found the total cost by multiplying the number of hot dogs by 2. The cost in dollars per hot dog. So if there are n hot dogs, the total cost in dollars would be n times 2, or normally we write it 2n. Example 2. A person flies at a constant speed of 75 miles per hour. Find the distance traveled in 1, 2, 3, and 4 hours of driving at that speed. Show the arithmetic to help you see the pattern. Organize the calculations in the table and include an expression that stands for the distance traveled in t hours. First, we want to make a table. So if we drive 1 hour, that would be 75 times 1. Drive 2, 75 times 2, till we get to t. So from the last row, we see that the expression 75t, or 75 times t, represents the distance measured in miles traveled in t hours. So this is a constant, 75, and the driving time is our variable. We evaluate an expression by substituting the number for each variable in the expression and then calculating the result. If a variable appears more than once in the expression, the same number is substituted for that variable each time. When we evaluate an expression, it's a good practice to use parentheses for each time a number is substituted for a variable. So here's the 4 rules for using math to find results for an authentic situation. First thing we want to do is describe the situation in English. The second, we want to translate the English description into mathematics. Number 3, we perform mathematics to get a desired result. And number 4, we translate this mathematical result into English. Let's look at an example. Example 3. Some students rent a house together. Each roommate pays an equal share of $1,200 monthly rent. Number 1, let n be the number of roommates. Use a table to help find an expression that illustrates each roommate's share measured in dollars of the rent. Number 2, evaluate your expression in problem 1 for n equals 5. What does the result mean in this situation? So the first thing we want to do is identify what is the independent variable, and that would be the number of students. The dependent variable would be the amount a student pays. So first we make a table. We're going to show the arithmetic to help us see the pattern. So when there's one roommate, that is going to be 1,200 divided by 1, which is 1,200. For 2 roommates, the rent would be cut in half. 1,200 divided by 2, 600. If there are 3 roommates, that's 1,200 divided by 3, which is $400. If there's 4 roommates, Now it's split 4 ways. 1200 divided by 4 is 300. And if we talk about n roommates, that's 1200 divided by n. This is our expression. Number 2, if we substitute 5 for n in our expression, we have 1200 divided by 5, which is $240. So to interpret this, we would say each roommate would have to pay $240 per month. Lesson objective number 2. Definition. If A and B are numbers, then the product of A and B is AB. We call A and B factors of the expression AB. The quotient of A and B is the expression A divided by B, where B is not 0. Otherwise, this would be undefined. Here's some common English phrases and their corresponding mathematical meanings. So for the operation addition, we could use the word plus. This is an important word, sum. So sum means the addition of two numbers. Total also means addition. 3 more than a number means x plus 3. A number increased by 3 is x plus 3. So all these different English phrases actually are equivalent to the same mathematical expression. For subtraction, we can use the word minus. The popular word for subtraction is difference. 3 less than a number is actually x minus 3. A number decreased by 3 would be x minus 3. Let's look at 2 more operations. Multiplication, of course we can say the word multiply. Times, product is used a great deal. So the product of 3 and a number is 3x. Twice a number would be 2 times x. 1/3 of a number is 1/3 times x. Division, of course we can use the word divide. Quotient is very popular, so the quotient of a number and 3 is x divided by 3. And ratio of a number to 3 is x divided by 3. Let's look at an example. Example 4. Let x be a number. Translate the English phrase 4 more than the product of 2 and a number into an expression. So only one of these are correct. 4 more than the product of 2 and a number would be number 3. Product of 2 and a number is 2x. 4 more than the product of 2x would be 2x plus 4. Number 2, evaluate your results in example 4 for x equals 3. And number 3, evaluate your results in example 4 for x equals 7. So all we have to do is substitute these values in for x and the expression. So 2 times 3 plus 4 is 6 plus 4, which is 10. And for number 3, 2 times 7, which is 14, plus 4 is 18. Example 5, let x be a number. Translate the English phrase or the sentence into an expression. Then evaluate the expression for x equals 6. Number 1, the quotient of a number and 3. Number 2, subtract the number from 8. So the expression for number 1 is x divided by 3. And if we evaluate this expression, when x is 6, we have 6 divided by 3, which is 2. Number 2, the expression is 8 minus x, because we are subtracting x from 8. So if we were to evaluate this, this would be 8 minus 6, which is 2. Example number 6, let x be a number. Translate the expression into an English phrase. Number 1 is 6 minus x. Number 2 is 8x plus 5. So we can say the difference of 6 and a number, but note that there are different ways of saying this, thus there's more than one correct answer. Number 2, we can say the product of 8 and the number increased by 5, and again there's more than one correct answer. Example number 7, if it takes a student t minutes to complete a test that has n questions, then the expression t divided by n is the average time measured in minutes taken to respond to one question. Evaluate t divided by n for t equals 48 and n equals 16. What does this result mean in this situation? If we substitute 48 for t and 16 for n in our expression t divided by n and calculate the result, we get 48 divided by 16, which is 3. So to interpret this, we would say it takes a student 48 minutes to respond to 16 questions. The average response time is 3 minutes per question. Example 8. Write the phrase as a mathematical expression and then evaluate the result for x equals 8 and y equals 4. Number 1, the sum of x and y. Number 2, the quotient of x and y. The sum of x and y is the expression x plus y. If we evaluate when x is 8 and 4, we have the result of 12. Number 2, the quotient of x and y is x divided by y, and evaluate, we have 8 divided by 4, which is 2. Here is the reading and suggested problems from the text. Thanks for watching.